Hi. As a relatively new owner of the Haken Continuum, I thought I'd put together a set of videos on various subjects related to it, starting out with some tips and tricks as I've encountered programming the incredible EaganMatrix front-end synth to the Continuum. Now, I'm not the world's greatest programmer of this thing yet. I've only been doing this for a little over a month, and there's a world of knowledge to be obtained to do this properly. You have to know a lot about acoustics, a lot about sound design, computer music, all kinds of synthesizer techniques and technologies. But no matter what level you are playing the Haken Continuum, even if you don't want to program it yourself, you just want to sit down, use the presets, and make music, which is great. I am convinced that a little knowledge on how to program the matrix will greatly help you increase the sonic potential of the instrument and your ability to take stock factory presets and alter them, create new sounds with relative ease. So let's get right into it. On the screen now I have the Continuum's editor that will come up once you install it and connect it correctly to the MIDI interface. We won't talk about that right now. So let's just start by bringing up an empty patch. Go to the factory presets that we all love and find the empty one there and bring that up, and you'll see that the matrix part of the editor is blank. If you don't see the bottom part, it's probably because you don't have this little triangle selected that shows you the whole screen. Now, there's a lot of stuff on the editor that will leave for later, particularly all these dials, controls, and barrels that are programmed through the matrix. We're going to be interested initially just doing some simple things, programming the matrix to get sound out using constants and predefined formulas. Now you can create your own formulas over here to do all kinds of different things, but we'll leave that for later. When you're presented with this thing, and the first time I saw it, I was utterly delighted with the complexity yet elegant simplicity of it, but also very confused into how it really works. When you read the manuals, and everybody should read the manuals that come with the firmware distribution, and also go online and find some videos by Ed Egan, who created this masterpiece with Lippold Haken, and certainly start there. Now, my videos are going to come from a little bit different perspective than the wonderful ones that Ed creates. I'm starting at ground zero and on the bottom floor as if I know nothing, which is close to the truth, and going upwards, whereas Ed, who knows pretty much everything, is tailoring, going downwards. When you're presented with this screen, if you read the manuals, they tell you, okay, you connect inputs on the left to outputs up top through matrix intersections. Now, I was totally confounded at the beginning, because to me, things on the top seemed like inputs and outputs, the same with things on the left. So I kind of just think of it in terms of routing something to something else, and I'm not even really concerned about inputs and outputs. I'm just concerned about what the functions of the modules are, and it gets to be pretty second nature after you've done it for a little bit. The most important outputs that you route things to are the main outputs, left and right. You can't get much out of the thing without going through those. There are also circulator, delay controls, and secondary outputs. We have our oscillators and various banks that produce sound in various ways. Also can be set to filters. Some modules can be set to different kinds of delays that Ed and Lippold are constantly updating, and important shape generators at the end that can be set to create repeating patterns and other dynamic response things, almost some envelope-like things. Very important to create complex and dynamic sounds. Let's start, though, by doing something simple. We're not even going to use the fingerboard at first because you don't need the fingerboard to get sound out of the matrix. All these modules up top here, if set to the right numbers, are ready to generate sound. But we'll start by just looking at the noise generator, which allows you to create white noise or filtered noise if you can run it through some filters. Now, something to be aware of, especially if you wear headphones when you're playing and programming the matrix. If you type the wrong thing in there, or you're not exactly sure what you're doing, you can create incredible sonic explosions that are deafening. So the best thing to do starting out is err on the side of caution and start by typing small numbers into the matrix. We'll do just that right now. So let's go to where the noise routes to any one of these modules, but we're going to route the noise to the left and the right outputs. And we'll use a small number that will map to some amplitude percentage of that noise going to the outputs. Something like 0.5 will be fine. So we'll type 0.05 and we'll get a little bit of noise. You can hear that. We'll put that on the other channel. Now, as you see, the second I type something into the matrix, it takes effect. Let's type a smaller number. 0.01. 0.01. And of course, the sound lessens in volume. I could type a larger number, but I don't want to do it in this case because noise can get very loud. Hitting the delete key on an intersection will delete my input. And there you go. Very easy to get sound out of the matrix without touching the fingerboard. Now, noise is very important for generating a lot of sounds, but we won't worry about that for now. Let's start looking at the oscillators, which is a little bit more interesting thing to do since we can set that to some pitches and play around a bit more. There are 5 possible oscillators here. As you see, anything in red in the matrix are things that you can change in one way or another. These 5 oscillators can either be set as oscillators or filters of some sort. We're going to worry about them being oscillators right now. So let's go to oscillator number 1 here. And the first thing that we'll worry about is setting a frequency there. If you notice, when I put my cursor over one of these little dots, you'll get a nice little tooltip, which is wonderful, so I don't have to constantly consult the manual set. The frequency is entered in kilohertz, so let's go down here and to the direct column and rows and put a number in down there. Now, something you type in a direct row is going to be directly applied to the total output of your module, whatever you're applying it to. And we're going to type in here a value of 0.11. That will map to 110 hertz, since we're entering things in kilohertz. No sound comes out yet because we haven't routed anything to the outputs. So let's do that, and hopefully we'll get a 110 hertz sine wave, which is the default oscillator waveform, coming to our outputs. Now I don't want to go to the noise column because I want to route my oscillator 1. So as you see here, we have 5 possible oscillators, 5 routes that can be associated with each one of those. We have an A, B, and a C module. Those are here that can be routed to things. And we have our AAS inputs and other inputs, secondary inputs, and the direct items we talked about. So now if I type in a small number, 0.05, oh, well, you can see nothing comes out. And why? Because it's easy to type something wrong into the matrix. And I typed a 1-1 on the second oscillator, but I routed the first oscillator. So let's remove that and go to the first oscillator and type the 1-1 there. And I get the sound I expect. Okay, let's put that on both channels. Okay. I can delete that by hitting the delete key. Now anything in the matrix that doesn't have value is assumed to be 0. So obviously if I'm routing a frequency of 0 to the oscillators, I'm not going to hear anything, and I don't. Let's type in an octave above that, 0.22. Now listen to what happens when I type. The first value, when I typed 0.2, I got a value, a frequency instantaneously of 200 hertz, and when I typed the second digit in there, then it went to the right frequency. So the split second you type anything into the matrix, it takes effect, which is great because I can program things in real time and do a lot of things. The second I type something in there, I can hear my result. All right, so let's play around with the direct column a bit, because as you see here, I have values that can be additions, subtractions, or a multiplier. Now when I type something in the addition column, if it's just the first thing I type, that's going to be, in effect, be setting the module to that value. So let's type in our 0.11 again and play around. One of the things I can do, let's say I want to increase that by an octave. One of the ways to do it is to simply multiply that by 2. So I can type it 2 in my multiplier column. All right. I can do the same thing by adding the same value to itself and get an octave that way. All right. Makes sense. One thing that you should be aware of is you can't type whole and fractional parts as constants into the matrix. You'll have to set that up either through some other formula, or if you want to type a constant in the direct line, you can have to type, say, let's say I want 1500 hertz. I can type a 1 on one line, and in the addition column put a 0.5. So now I get 1500 hertz coming out. Right. It would be nice if in some future release these plus, minus, times options were also turned into settable things. I might, for example, want to have 2 multiplications here, or 2 subtractions, not 2 additions. I suspect that's possible. It'd be a nice little feature to add at some point, though not earth-shaking in terms of need right now. Okay, so we've typed in values here, and right now, no matter what I type, all I can do here is pretty much turn things on and off. All right? Not very musical. All right? What I really want to do is start playing around now with some of the preset formulas that control the fingerboard, so I can start playing on the continuum itself. So what I'll do is delete my constants to output here, and I'll type in W instead. W is one of the 4 predefined formulas, W, X, Y, and Z. These you can type into the matrix in various places, and they will affect the fingerboard in 4 different ways. So now if I type in the first oscillator, my frequency again, let's type, say, 440, a nice A in there. Nothing's coming out now because I need to touch the fingerboard to get a sound. So let's do that. Okay. Let's turn that volume down a bit. You can see W is a predefined formula that's just basically a gate. It turns the note on, and when I lift my finger, it turns the note off. Maybe a little more volume. No matter how hard I press, whether it's light or deep into the fingerboard, I get the same volume out, because it's just a gate on at full volume, whatever that volume would be based on your gain setting. And if no matter where I touch the fingerboard now, I get the same tone out. Why? Because the only frequency that I have it set to is 440 hertz. So what I've done here is of limited musical value. I can basically play an A. Maybe I can use it to tune an orchestra if that need ever comes about. All right. Let's use another predefined formula, Z. Now, Z is a much different animal. Z responds to finger pressure. So now when I play a note, if I just play lightly on the fingerboard, I'll get a note low in volume, and as I press harder, volume will increase, and obviously the reverse as I lift my finger off the fingerboard. Okay, well now we're really cooking, because this allows us to create something with great expression and use very fine diminuendos and crescendos, and one of the wonderful things about the fingerboard. But again, it's useless for me to try and do anything fancy with vibrato, because my frequency is set to 440 hertz, and no matter what I do, now all I can do is create a very nice expressive A. So let's go to the third predefined formula, X. This one is used all the time in all different places, and what that does is it basically maps the frequency of the fingerboard into your frequency that you're using in the matrix, and most of the time that frequency works out to map to the fingerboard template if you have one. Right. So now I can play that sine tone with pretty good expression. My Z is active, so I can play soft, I can play louder, and of course I can get that wonderful continuum vibrato out. Pretty nice. About the simplest patch you can make. And in fact, let's go and bring up the sine wave. Hey, it's exactly the same thing. All we did in that first 20 minutes or so of discussion was recreate the factory sine wave patch. But let's play around with that for a bit and see what else we can do with it. As we said, the oscillator defaults to a sine wave if its S setting is set to 0, which of course it is now since nothing's in the column. As you increase that from 0 to 1, you're going to go more in the direction of a a pulse wave. At point 1 or 2, you're getting more of a triangle kind of wave. At let's go to say point 5, it's going to become a lot more buzzy. And at point 8 or so, we're, as the documentation says, at a pretty much a full sawtooth wave. Okay, nice, but I don't want to have to type numbers in every time I want to change my waveform a little bit. So what can I do there? I'm going to bring in that fourth predefined formula, y. Okay, so let's get rid of our number there, and we're going to use y as a multiplier. Okay, when I play now, it's only playing a sine tone. It's not really changing anything. Why? Because the rest of the column is set to 0. So y as a multiplier is only going to multiply by 0. So the only thing that's going to ever be set with this setting is 0, my sine wave. So let's do something simple. Let's type a 1 here in my plus column. What this is going to do is set the waveform column to its max value of 1. However, that's also going to be multiplied by y, which goes from 0 to the front of the fingerboard to 1 at the back. And now you can see we have a much different kind of sound going on. At the front, where y is pretty much 0 times 1, I'm going to still get my sine wave. But as I increase now, basically, my finger is tracking the value of y. Which is nice because now I can actually play a moving waveform. Nice. In fact, what I could do, because W gives me a gate to 1 anyway, I can bring in now all 4 of my predefined formulas on one simple patch. Okay. What else can we do? We still have one remaining column in the oscillator, this triangle. What this triangle lets you do is modulate the oscillator by some other sound source. So let's do something simple in terms of modulation. It's actually a phase modulation that's being used here, but that's very similar and identical in some ways to frequency modulation. So you can, I think of it kind of like a frequency modulation. Let's modulate oscillator 2 by the value of what we have set here in oscillator 1. All right, how do we do that? As you know, right now we have the first oscillator routing to the outputs. So let's remove that, because we really want to route whatever the second oscillator is now generating to the outputs. So we can put our Z's on 2, the second oscillator, and now where 1 before was routed to the outputs, I'm going to route my 1 to the input of that second oscillator. All right. Now when I play, I also want to set that second oscillator to track the fingerboard. All right. Let's see what this sounds like. I'm still tracking sound on Y, but now you can kind of hear that much more buzzy, modulated kind of sound. Modulation can create some very messy kind of sounds. Really complex vibrations going on in there. So let's do one more thing. Right now, I'm routing the full value of this oscillator's amplitude to the second oscillator. The sound is changing because Y is still controlling the waveform that I'm modulating the second oscillator by. We can use the Y formula one more time here. Apply that to the modulating source. So now Y, which is 0 near the front, is going to be modulating more like with a sine, and as I move to the back, I'll get my change in sound. At the top, you can hear a lot of complexity and vibration and fuzziness that I might not want for a melodic kind of a sound, but it could be very useful for some other kinds of sounds. But this is a kind of an interesting patch in and of itself because it has a very brass-like sound, about a quarter of the way up to halfway up. Kind of trombone-y down here, but up top, really brass-like. Hey, I kind of like that patch. I think we can do something with that when we play around with it a bit more. And maybe we'll do that on the next session. So there you have it. The use of predefined formulas and constants to create a pretty simple patch in the matrix. And as Ed Egan has stated in a number of his videos, you don't have to type a lot of stuff into the matrix to get some pretty nice and even complex sounds out. Maybe what I want to do now is, since I think I want to keep this, I'll go to the preset save option, and I'll save that to some file that I want to keep for later. And now I have it. We'll use that at some other point. I think that's enough for now. And next time, what we'll do is we'll start looking at some simple formulas and maybe how to control some of these barrels to let you dynamically change things when you're playing. Okay, till the next time.